This video is for section 13.2, the nature of liquids. Learning goals are to know the causes of the physical properties of a liquid and to understand evaporation, dynamic equilibrium, and boiling. Let's take some notes on that first learning goal. Know the causes of the physical properties of a liquid. Physical properties of liquids are caused by the motions of the particles and the forces of attraction between the particles. One physical property of a liquid is called vaporization, the conversion of a liquid to a gas, or another word for gas is a vapor. It is a property of liquids that they can vaporize. They can change from the liquid state to the gas state. Here's the cause of that. Particles in the liquid can gain sufficient kinetic energy to overcome the forces of attraction to the other particles in the liquid. When a substance is in the liquid state, the particles that make up that substance are very close together, yet they're able to flow around, unlike in a solid where the particles are more locked into position. Particles which are close together can be attracted to each other, but with enough kinetic energy, the particles will move around enough that they can overcome those attractions, and some of the particles can change into the gas state and float off into the environment. Evaporation is vaporization that occurs at the surface of a liquid, and its cause is the same as above. When the particles in the liquid have enough kinetic energy to overcome the attractions between the particles so that some of them can escape from the surface of the liquid and float off into the environment. Another property of a liquid is that it has a vapor pressure. When a liquid vaporizes in a closed container, the vapor particles will collect above the surface of the remaining liquid. As these particles move about, they will collide with and exert pressure on the surface of the liquid. This is called vapor pressure. Let me make a quick sketch. Here is a container. The container is partially filled with a liquid. Here's the surface of the liquid, and here is a bunch of particles within that liquid. When some of the particles vaporize, they'll escape from the surface and they'll float around in the space above the liquid. As they're moving around and bouncing around, several of them will hit the surface of the liquid, exerting pressure upon that liquid. That's vapor pressure. Another vocabulary word is dynamic equilibrium. This is the condition in which the number of particles turning into vapor is equal to the number of vapor particles turning into a liquid. Another way to explain this is, it's when the rate of vaporization equals the rate of condensation. Vaporization is the process of liquid turning into gas. Condensation is the process of gas turning into liquid. Here are some check for understanding questions. I'll pause the video for you to answer these, and then we'll discuss them before continuing on with the lesson. Number 1, what happens to the rate of evaporation when the substance is heated? It increases. When more heat energy is applied, the particles have more kinetic energy, they move around more and can overcome the attractions between them, allowing more of them to evaporate from the surface. Number 2, what happens to the vapor pressure of a substance in a closed container when the substance is heated? The vapor pressure will increase, because when heat is applied, more particles will change into vapor. If there's more vapor particles, then there will be more collisions with the surface of the liquid, and that increases the vapor pressure. Vapor pressure is a good indicator of the volatility of a substance. A substance that isn't volatile does not evaporate easily. It has a low vapor pressure because not much of the liquid will change to vapor particles that would exert pressure on the surface of the liquid. A substance that is highly volatile evaporates easily. Many particles change into vapor and exert pressure on the surface. Here are some check for understanding questions. I'll pause the video for you to answer these, and then we'll discuss them. Number 1, at 30 degrees Celsius, the vapor pressure of water is about 5 kPa. The vapor pressure of gasoline is 40 kPa. At this temperature, about how many times more volatile is gasoline than water? 40 compared to 5 is 8 times more volatile. Which substance evaporates faster? That's the gasoline, the one that is more volatile. Number 2, did you know that areas of the country in which there are large temperature changes between winter and summer have different mixtures of gasoline for winter and summer? In the winter, gasoline needs to have a higher vapor pressure so that it vaporizes easily, so that engines can start in cold weather. In the summer, gasoline needs to have a lower vapor pressure so it doesn't vaporize as easily, which would clog the automobile's fuel lines with vapor. Summer blend gas contains 1.7% more energy than winter blend gas. Which gasoline blend would give better gas mileage? The answer is the summer blend gas, because an equal quantity of that gas contains more energy. In Michigan, your car can drive a little bit farther on a tank of gas in the summer than it can in the winter. The next vocabulary word is boiling point. Boiling point refers to a temperature. It's the temperature at which particles in a liquid have sufficient kinetic energy to vaporize. A substance boils when its vapor pressure exceeds the external pressure on the surface of the liquid. For example, the reason that the boiling point of water is 100 degrees Celsius when the surrounding pressure is 101.3 kilopascals is because at that temperature, the particles in the liquid have sufficient kinetic energy to escape the attractions of the other water particles and to overcome the force of atmospheric pressure that works against the vapor particles escaping from the surface. Let me draw a quick sketch, this time of an open container. The container is partially filled, and here's the surface of a liquid, and here's a bunch of the particles of the liquid. Above the container is just air, the atmosphere. That air pressure will press down against the surface of the liquid, and that pressure down hinders the ability of the particles in the liquid to escape from the surface and move up into the atmosphere. The boiling point is the temperature at which there's enough energy in those particles that they can overcome that downward atmospheric pressure, and despite that force downwards, the particles can still escape from the surface and float up into the air above. If the temperature of water is less than 100 degrees, then the particles within the water don't have enough kinetic energy to overcome that downward force of atmospheric pressure. The particles are not going to vaporize and escape into the air. They're going to stay down here in liquid form. If external pressure is increased, then the boiling point of a substance increases as well. For example, when food is cooked inside a pressure cooker pot, the boiling point of the water in the pot is higher than 100 degrees Celsius, and more heat energy can be supplied to the water, which causes the food to cook faster. Let me draw a sketch of this idea. Here is the pressure cooker pot, and it's going to have a lid which can be screwed on very tightly so that no vapor can escape from that pot. Inside the pot, here is the surface of a liquid, and here's a bunch of particles of that liquid. As heat is applied, particles of the liquid will vaporize and start to fill up the space above the liquid. Those particles will press against that liquid, exerting vapor pressure. Because none of the particles can actually escape from the pot, as more and more heat is applied, there are more and more vapor particles pressing against the liquid. That increased pressure makes it more difficult for the liquid particles down here to vaporize and escape up above the surface. It's going to take more heat energy for those particles to vaporize. The word for that's boil. It's going to take more heat energy or a higher temperature for all these particles to boil and change into vapor form. This concludes the lesson about some of the properties of liquids, the ones that are caused by the particles in the liquid. Concepts that were discussed include vaporization, evaporation, and vapor pressure.